integrity is everything. Our way of life in this country rises and falls on the integrity of our leaders and the integrity of our infrastructure. Because integrity impacts everything, this is the Integrity Podcast, powered by EXO, hosted by Zachary Oliphant.
All right, everybody, welcome to our podcast. Today is an awesome opportunity, first interview we've done. It only seems right that the first person we'd interview would be Wes Oliphant. Happens to be my dad, great mentor to me over the years, great leader in our industry. And I think everyone listening to this will find some interesting insight in what he has to say, how his career has navigated the industry over the last 45 plus years. And I think any young engineers out there will really love to hear what he has to say and his perspective on the industry. Certainly, we get to take advantage of all of Wes's expertise every day, which is fantastic. And so for any of you that may not know who Wes is, let me just read off his bio. There's too many acronyms and too many credentials to not get it right. So Wes Oliphant is a professional engineer here in the state of Texas. He's also EXO's chief technical officer and co-founder of EXO. He's been involved in numerous innovative firsts over his career related to the design, testing, manufacturing, installation, and ongoing inspection and maintenance of poles and towers used in a variety of infrastructure applications. He's also a fellow and life member of ASCE, a charter member of SEI, and again, a professional engineer in Texas. He currently serves as the chairman of ASCE's SEI's Committee of Electrical Transmission Structures and a member of ASCE's Committee of America's Infrastructure. He is also representative to IEEE's Subcommittee 5, Strengths and Loadings, and the National Electric Safety Code. He's been the inventor, co-inventor of more than 8 U.S. patents related to steel and concrete poles, as well as several other inventions that will probably be patented in the near term. And in 2010, he was honored to receive the ASCE SEI's Gene Wilhoit Innovation and Transmission Line Engineering Award. That's a mouthful. And it goes without saying, all of these credentials, probably the most important one to me is what my kids call you, which is Pop. And so what a fun opportunity to have somebody on our show that has this amount of experience. And certainly I've been able to take advantage of that over the last 20 or 30 years of my career. And I think the folks listening will learn a lot. So let's start, Wes, on, where did it start for you? Give me your background, where you're born, where you went to school, and what was the catalyst to get into engineering?
Well, there's a lot of questions in that question, but I'm a oldest son of 3 children of James Oliphant and Patsy Oliphant, my parents, and my dad was in the Air Force for close to 30-something years. They met in my grandparents' hometown of Marshall, Texas, and they fell in love, but my dad went out to Tucson, Arizona in the Air Force, and my mother followed him out there, and about a year and a half after they got married, I was born. So so I'm a military brat, so to speak. Traveled around with my parents when Dad was traveling all over the U.S. and foreign countries. How I got into engineering is, I think I've told you this before, but I love the outdoors. I wanted to be a forest ranger growing up, and but I got into high school, and my high school guidance counselor said, "No, you're pretty good in math and science. You ought to pursue a technical career." And next thing you know, I was enrolled as an engineering student in college.
Sounds good. And you ended up going to Texas A&M University. Kind of walk me through that experience for you on, heading towards the Air Force as well as the engineering component of going to school.
Yeah, the Air Force was, obviously part of my background, and I wanted to essentially follow in my dad's footsteps, so I got an Air Force contract. Went to Texas A&M, graduated in 1974. My first assignment as a civil engineering officer was Keesler Air Force Base in Mississippi. But as those of you that are old enough to understand, 1974 was a pretty turbulent year as the Vietnam War was winding down, and so I went in there. So I went in as a brand new second lieutenant, civil engineering officer, as I said, and but soon thereafter we started pulling troops out of Vietnam. And 1975, we were completely out. The Air Force started seeing that and asked for volunteers to leave the Air Force. And as a brand new engineer, I said, I don't want to necessarily make the Air Force my career. My wife, your mother, was also an Air Force dependent, and we had made the decision we didn't want to do nearly as much traveling as our parents did. And so I got out of the Air Force and started my professional career.
Now, walk me through. I mean, obviously, 1975, you couldn't just hop on the internet and find your next job. So,
no, you couldn't.
And you probably weren't expecting to be out of the Air Force after just a couple of years. So, walk me through first job experience and what that taught you.
No, as you're absolutely right. There was no internet searches at that time, and I can't remember actually how I found the job, but I got out of the Air Force. Unfortunately, it was very, very quickly. I raised my hand to get out of the service, and within, I think, about 4 months, I was out. But I had very little notice. Once I got the notice, I knew I'd volunteered to separate, but I didn't think they would accept it, to be quite honest, because I had a 4-year contract to stay in. But when they accepted it, I was out within 45 days. And so all of a sudden I was unemployed and actually had a baby on the way. Your older brother, Scott, was expecting. So I had to find a job very quickly. I don't know how I found it, but I ended up going to work for Campbell Soup Company up in Paris, Texas. They had a very, very large wastewater treatment operation. As a civil engineer, I had studied that to some extent. And it was a job, and I took it, and I learned very quickly that's really not what I wanted to do. But it was a job. It paid me well. I enjoyed it, and I also enjoyed learning something new. But from that, I went back to the Texas A&M Placement Service. That's how you found a job back in that day when you were out of school, and they pointed me to an opening here in the Houston area with a company called American Pole Structures, which I came down and interviewed and took the job.
So
and that's how I got my career in the steel pole industry.
So 1976, you get into the structures business, servicing utilities. Kind of walk me through. I mean, a lot of folks, especially young engineers, probably don't understand that was really kind of the early stages of the steel structures manufacturing, especially tubular steel product manufacturing. It had been around for 10 or so years, 10 or 15 years. But kind of walk through those early days, especially juxtaposing that to today, the use of software and whatnot.
Yeah, it was, and actually that's what I really liked about it. It was, there were very few standards. In fact, there were no standards at that time on how to do what we were doing. So it was, the steel pole industry got it started in the late 1960s with a company called Union Metal up in Ohio and Meyer Industries up in Minnesota. But American Pole was a relatively new startup. They started in '69. I joined them in '76. So they'd only been around 5 or 6 years. And But they, the steel pole, the industry was changing. The transmission structure business was changing. When I joined, the predominant type of structure was the lattice type structures that you see made of angles and structural shapes, and wood poles. That was the two predominant types of structures. And steel poles were gaining in prominence simply because they looked better, they took up less right of way, they could be made more compact, so the lines could be more compact, and generally the aesthetic appeal was what was driving it. So the steel pole industry at that time was getting its foothold in primarily very urban or suburban areas where aesthetics was playing a bigger and bigger part. They were a lot more expensive than wood poles and lattice towers, but the aesthetics was driving it. But when I joined, we were also starting to see some transition to using it for the labor savings that it represented over constructing lattice towers, and the fewer components to assemble meant that they could be assembled much more quickly and still have an aesthetic appeal that lattice towers did not.
So walk me through, as a young engineer, you show up and all of a sudden you have to figure out how to design structures with no standards. Walk me through that process. How did you all do it? And what were some takeaways that you learned in that experience?
Yeah, so I still had my slide rule, but calculators had come on the scene, so I actually had a calculator and a slide rule, but the calculators were pretty rudimentary still. But everything was done by hand. All the calculations were done by hand. So we were designing structures the old-fashioned way. You would essentially figure out the loads, apply the loads, figure out the reactions on the various components, and then determine what kinds of section properties you needed to be able to resist those loads and maintain those reactions. So a lot of hand calculations, a lot of plotting of moment curves and shear curves and things like that, which I look back on now was actually very, very beneficial to me to be able to learn, although I did it in school, but to be able to learn in a more understanding way of actually how structures behaved. So
now I assume as part of that, as you all are designing and trying to iterate and test, there's probably quite a bit of testing going on as well to try to confirm your design assumptions. Kind of walk me through that experience and what you learned over the years through testing.
We did a lot of testing. You're right. That was essentially how a lot of the designs were verified. Is you design a pole or a set of a unique connection on a pole, and you'd build it and go out and pull the loads on it and see if it broke. Mm-hmm. And I love that part of it, being able to verify what you thought was going to happen, seeing if it really did happen that way. In buildings and bridges, you don't get a chance to typically test a failure. Poles and towers, you do.
Yep.
And we do accept failure on utility structures as opposed to buildings and bridges and other kinds of that type of infrastructure, because we want to do it in a very cost-effective manner that doesn't over-design things.
So unpacking this, especially for a young engineer that maybe is using software today to iterate designs, and maybe that's a industry-recognized software, some sort of proprietary software, the value of all of these hand calculations and all this iterating and testing, what would you tell those young engineers today as far as what that taught you and what value that brought your career?
Yeah, I mean, I look back, and it was probably one of the most valuable periods of time in my engineering career, because I had to sit down and you perform those calculations, it makes you understand, what the inputs are. It also gives you a little bit of an understanding. You have to have a little bit of predisposition of what the outputs are going to be as well. And so you get a little bit more of the side of reasonableness in everything that you're doing. I think software today has taken a little bit of that away. You program loading inputs, you see a color-coded output. If it's red, it means it doesn't work, but you don't have a sense. You don't have the sense of how it got there.
Yeah.
And not necessarily, but I think again, a lot of young engineers go through that exercise, but I certainly would encourage more to get involved in understanding the both the inputs as well as the reasonableness of the outputs, understanding how things work. The behavior of structures is, pretty well defined at this point, but at the same time, you need to understand what's going on to be able to design effectively.
Sounds good. Now, walk me through. So that's kind of the engineering view of your early career. Walk me through from a kind of a welding and fitting perspective and working at a factory. And I remember as a little kid, I think so we'd stay out of your hair. You'd bring us to work on a weekend, and we'd make paper airplanes out of big drafting paper and throw them off the second story. I don't know how we didn't get you fired, but kind of walk me through what that experience was to be an engineer at a facility that was manufacturing and what value that brought.
Yeah, this industry is unique in that sense that normally engineers are designing and somebody else fabricates. Again, the building and bridge industry is kind of like that. But the utility structure industry is turnkey from that standpoint. You're giving a set of parameters, and you design the structures. You detail it, prepare the drawings. It goes out to a shop. They fabricate what you've designed and detailed, and and then you get a chance sometimes to go out and seal in a field and see it erected, and ultimately get the line strung in and watch it perform its job. So it is pretty turnkey in that sense. I had a very unique opportunity to work for a mentor when I first joined American Pole Structures that taught me the lesson of going out into the shop every day. And he made sure that he and I walked out there. We took a 45-minute break every day and walked out in the shop and watched fabricators fabricate the stuff we were designing, and talking to the fitters and the welders and the quality folks, and make sure that we understood what the pain points were of the things that we had created, and all in an attempt to try to improve the next time we did something along that line.
Yeah, now walk me through those interactions. When you're interacting with fitters and welders and quality folks on the shop floor, sometimes, and we see this all the time when we're in facilities doing auditing and things, there's sometimes a separation between the office staff and the folks on the shop floor. Kind of walk me through how that impacted you as you moved through your career, having those daily interactions and what value that brought.
It was wonderful. Most of those guys are not bashful to tell you what they think, and in very creative ways they'll tell you what they think. And sometimes you don't want to hear it, but it's very honest and very open, and again, it's a lesson learned that I think that I still cherish today. I think it taught me, when you graduate from engineering school, you think you know everything in the world, and then you get start to doing things, and people tell you don't know everything that there is to know, and it can be humbling. But it's also important to learn that lesson. There are people that may not have the they may not could tell you what the thickness of steel needs to be, but they can certainly tell you a better way of making the parts that you've designed. So I think that was extremely important. And again, I look back as really a fond memory.
And you bring such a practicality to the engineering I've seen over the decades, and have worked with lots of different engineers. And I think it stems directly from that application and interaction and listening to folks that aren't just engineers or aren't engineers, and it's fitters and welders and construction folks and linemen. That perspective and that ability to listen and take their criticism. Sometimes it's harsh, but take their criticism and think about it and come out stronger, I think has been, I've seen it be really valuable in our business, and how our business tries to solve unique challenges. So walk me through. So you've had this experience in engineering, you're getting this exposure to operations. At what point does your role change? Obviously, you didn't always stay as a design engineer. You made a transition into other things. What spurred that change to happen? And when you look back on it, what are your thoughts there?
Well, I have to smile when you ask that question because, again, I spent a lot of time out in the plant. As I mentioned, talking to folks out there. As much as they gave me grief, I would always give them grief if things weren't going correctly. And so one day, the president of the company comes walking into my office, and he said, "Our plant manager's leaving, and I want you to become the new plant manager." And I said, "Why me?" He says, "Because you complain about everything we do all the time. So we're going to make sure that we address those issues." And again, so I took that step. I wasn't sure I wanted to do that because, again, you want to do engineering work as an engineer, but I did take the step, and again, it was probably one of the best things that I did. I had dabbled in, as a small company, we got involved in a lot of different things from the business development side, sales. I got the chance to interface with a lot of customers. The design side, which was very technical. Now I was getting ready to move into a role of managing people and managing the quality of the products that we were producing. And I just enjoyed the heck out of it. I did enjoy, the lean times that came with that, and you had to figure out, okay, well, I don't need 120 people. I only need 80 people. Mm-hmm. And which 40 are you going to pick that are not going to stay with us? I didn't enjoy that at all, but it did probably more to reinforce that whatever we did, I needed to do it the best we can. We've transferred that to our own company. We got to be successful because a lot of people depend on us being successful. Mm-hmm. And so from that standpoint, that was a pretty good lesson learned as well.
So you move forward, and you're at American Pole till the late 1980s, and then they were bought out, and you end up transitioning to a new role. You stayed in the industry. You left the industry for about a year, but then got back in the industry related to concrete pole manufacturing. So I guess number one, as an engineer and as someone that had operations experience, what drove you to stay in the industry? Nowadays, talking to somebody that's been in the same career, various different roles for 45, 46 years, there's probably some young people listening to this that think that's insane. But kind of walk me through, why did you stay in the business, in the utility structure business?
Well, as you said, I did leave for about a year and a half, or almost 2 years, and but I realized that I really liked the utility business. I really liked the utility structures business, and partly is just the professionalism, the purpose that suppliers to the utility industry are serving. We and it's probably more important today than it ever has been, but we're becoming more and more electrified. I saw that way back early in my career that electricity was a pretty valuable commodity, and people that are working in that industry, probably don't have to worry about anybody ever not needing electricity going forward. So it was a pretty stable career. Your mother thought I was crazy. How many different poles can you design or manufacture? And pretty soon you'll run out of poles to manufacture and design. But here, 50 years later, we have it.
Yep.
So.
Absolutely. So you move into the concrete pole business, which was new to you. Interesting challenge there was working for a small company, Sherman Utility Structures, that eventually became a company called Newmark. But kind of walk me through. Now it's same industry, but completely different material.
Completely different material. And that was really what I enjoyed about that. Same structures, same purpose of the structures, but now a different material. These were centrifugally cast concrete, pre-stressed concrete, and again, stuff I had studied in school, but not on a particular application like this. And a good friend of mine, Doug Sherman, who worked with me at American Pole, had gone to work for Sherman Utility Structures, and as that company was starting to grow, they needed some more folks, and he contacted me, and I was ready to get back in the industry, and I came back. And I found out I really loved the concrete pole business as much as I did the steel pole business. In fact, we grew that company to the point where we ended up doing multiple different types of materials. Sherman Utility Structures made fiberglass composite poles, spun concrete poles, and ultimately we bought a steel pole company, and we were in the steel pole business again as well. So we had all three materials, and what I really enjoyed about that was being able to understand how all of those different materials could be used to their advantage on particular types of structures and different applications.
Absolutely. And then you flash forward a couple more years. You guys were so successful as you became Newmark that Valmont eventually acquired you all in 2003. And you obviously had a big role in that and helping Valmont grow their transmission business tremendously. Kind of walk me through that transition and then ultimately how you settled with Garrett and I.
Yeah. Yeah. So 2003, Valmont started the discussion with Sherman, actually Newmark at the time. It's a little complicated how all that came about, but we had just built a concrete pole plant out in California, Barstow, California, and I think it caught Valmont's attention, and they decided they better take a look at this little upstart company, and so they came knocking on the door and looked at our operation. They really liked what they saw in the utility structures business. At that time, Valmont was very big into lighting and traffic and telecom and a bunch of applications, but their utility structures business was actually smaller than Newmark's was. And so this was actually a pretty good strategic move on their part too, to acquire Newmark and become a bigger player in the utility structures business. And then combined, we became a very big player in the utility structures business. So that happened officially in 2004. The discussion started in 2003, but in April of 2004, the deal closed and we became Valmont Newmark. And my role changed a little bit over the first year or so of that, just as the transition of becoming part of Valmont was unfolding, but ultimately I was asked to move over into the steel operations. Valmont had they ended up moving, I believe, 6 different steel pole operations into the Newmark operations or Valmont Newmark operations, and I ended up overseeing all of the steel pole operations during that period of time.
Sounds good. And then as we headed in 2007, Garrett, your other son, your youngest son, and I, we were growing our traffic and lighting business that was starting to compete more and more with Valmont. And you always tell the story that you think we were having a little more fun than you were having. And
Y'all were having a lot more
meetings,
fun than I was having. And, I had, at that point in time, there were probably close to 1,000 employees in the steel operations. And again, my background being engineering, not necessarily an executive for a big publicly traded company. I miss the days where we could have a lot more fun about what we were doing. And you guys had gotten to the point where you're ready to take a couple more steps, and you weren't necessarily competing with Valmont at the time, but the handwriting was on the wall. If you got any bigger, that was going to happen. And so, so I made the decision to leave and join you and Garrett.
And really, most of your career has been kind of around small startup entrepreneurial type businesses that have then grown rapidly. American Pole was that way, and then sold. Sherman Utility, then Newmark was sold. And then as you joined us, there's probably a theme here. We continue to grow our manufacturing business and ultimately sold it in 2010. But let me take a step back a little bit around kind of the inspection part of our business, Exo Today, as we had sold off our manufacturing business. Kind of walk me through, from your perspective, how we got in that business, the value you saw that we could bring in that business, and how we could use our technical competencies that Garrett and I had developed over the years, and our staff, and then you joining us allowed us to service our clients.
Well, the inspection business actually was almost by accident. 2009, actually 2008, hurricane hit the Gulf Coast of Texas and knocked down a bunch of lighting poles and distribution assets, and did a considerable amount of damage from Beaumont all the way over down the Texas Gulf Coast. Somehow or another, a insurance agent or insurance company contacted us to go over and look at some poles that had fallen down at Beaumont High School, Beaumont Ozen High School, and wondered why they lost, I think it was like 14 of the 20 poles at their athletic, between the softball, baseball, football, and soccer fields. They lost a bunch of poles, where 3 miles away, another school that they insured didn't have a single failure. And so I got involved with that with them, and we determined that there was doing that investigation of the failure and root cause analysis, and determined that poles were not designed properly. They weren't specified to be designed to the wind speeds that Beaumont, Texas required them to be designed to. The other school 3 miles away was properly specified and designed. And so that helped them, and I really enjoyed doing that. I really enjoyed doing that investigative work. Having designed and manufactured poles gave us a lot of insight. And as luck would have it, about the same time, there was a rash of athletic field lighting pole failures starting to happen in the U.S., all over the U.S., primarily from a company that manufactured poles up in the Fort Worth area that shipped them all over the United States. But there were like a series, again, luck is better than smart a lot of times. And so we just happened to be at the right place at the right time, and all these poles started falling down, and we're getting more and more calls. And so we start looking at it. We said, hey, this is an interesting business. Let's create an inspection business to go out and look at all of these lighting poles that are falling down. And sure enough, developed a nice little business from it.
Absolutely. And you hit on a little bit here this design issue, and here on our podcast we talk a lot about integrity, and how for us as a business, really integrity is everything. And speak to me a little bit about how that has played out in your career from both an engineering perspective. You've done a lot of root cause analysis work and expert witness work, where you've seen people really bending their integrity for various reasons. Kind of walk me through how fundamental that has been in your career and what you've seen.
Really good question. And I don't know that it's so much bending it on purpose. You hope that it's not bending someone's integrity on purpose, but it does happen. I know it happens. But you think for the most part, it's just a lack of knowledge or a lack of understanding of what the good practices need to be. Yeah, I mean, I think again, when you look at a failure, something caused it, and whether it be a design issue, all of the athletic field lighting poles that were falling down all over the U.S. and they ended up being because people they decided they didn't need to design them per the recognized codes and standards that were required at the time. They could take a shortcut. And as a result of that, what they didn't anticipate was taking that shortcut caused those structures to become more susceptible to vibration and fatigue primarily, and other design-related issues. And within 5 to 7 years, a lot of those structures were showing signs of distress. And so the one good thing that came out of that, I petitioned the Structural Engineering Institute to initiate an activity to develop a standard for the design of athletic field lighting poles. Turned into be a standard for lighting poles in general, non-DOT lighting poles, because DOT is covered by AASHTO. But there was no one single reference to point to, and I'm very proud to say that standard, ASCE Standard 72, just got published in early part of this year. So we started that effort in 2010. Here it is, 2022, 12 years later, but there now is a standard for that design that people can reference. And it takes a while to develop a consensus-based standard. A lot of good, very talented folks served on the committee, and but it is a standard now. So, but your question on integrity, I think one of those lessons learned that everybody should learn is that you just can't sacrifice what it is that you know to be right, no matter what it is you're doing. You need to take a stand. There's lots of market pressures to do things incorrectly. You need the next job. You need to cut, cost. You need to do this. You need to do that. But ultimately, you need to do the right thing. And so we've built our business around trying to understand what that right thing is, and then making sure that people are following that standard.
Absolutely. Now, you talked a little bit about the standard that you developed on the and helped develop on the athletic field lighting or other lighting structures that are non-DOT. Kind of walk me through your whole career being on code bodies and standard bodies, and helping draft really what a lot of the industry uses today to design and build these structures, what that meant to you, and then what would your message be for young engineers that are using those standards or could get involved in some of these committees and standards that you're on?
Really good question. There's probably no more fulfilling task than to serve on a committee that helps write the standards that our industry uses. They are ever evolving. So if anybody out there is listening, there will always be another cycle of these standards to participate in and help get better. But in my career, that's evolved in helping write the standard, not the standard, but the ASCE has 3 levels of documents that they publish. A standard, which is a ANSI sanctioned activity that becomes a consensus national document that can become referenced by other codes. But there's also manuals of practice, and there's engineering reports, and generally the way you get to the standards is you start off with a report, becomes a manual of practice. Maybe you go through 2 or 3 cycles of that, and ultimately it gets elevated to a standard. But participating in those committees, you understand, or you get exposed to what all the behind the scenes discussion that goes into why do we want to do things a certain way, and why do we not want to do things a certain way, maybe even is a better understanding of certain things. But you get exposed to that, and I would encourage all young engineers to actively seek that out. Not only is it a good way of learning others in the industry, meeting other people in the industry that are doing the same thing you are, but it gives you that insight into what the industry best practices are, not from what you're reading in the codes and the standards and the manuals of practices, but what all the discussion that went in writing that. And sometimes that gets lost in what ultimately gets printed in a book.
Yeah, no, absolutely. And all those pushes and pulls in a conversation like that are really valuable. Everyone's coming with a little bit different perspective. And kind of walk me through, as you look back on your 45 plus year career, how continuing to learn, and you always instill this with anyone in our business, myself included, where don't assume you know everything. Assume that you've got to learn every day. And we try to deploy that to all of our folks and our clients, other young engineers, and a lot of the technical conferences that we participate out. How someone's been doing this for 45 years, you still continue to learn every day. Kind of walk me through the value and importance of that, especially if you were having this discussion with a young engineer right out of school.
Well, one of the most valuable things you can do is continue to learn, and I think the moment you don't think you need, or the moment you think you know everything, is the moment you need to stop doing what you're doing, because you don't. Part of the the investigating failures that I enjoy so much is because I get a chance to learn what didn't work right. And I will tell you, I designed things in my early career that didn't work right. One of the very first field assignments that I went on with American Pole Structures, probably less than a year after I had joined them, I had designed a structure sitting on a anchor-based foundation. I designed the anchor bolt pattern was an unsymmetrical pattern because that suited the design of the structure. But soon after it got installed, I got a call, or the company got a call, and the contractor had set the foundation 90 degrees off of the way that it was supposed to be set, and now all of a sudden the structure couldn't sit on it. And so we had to go figure out how to make this work. You had a very expensive pole and a very expensive foundation sitting in the ground, and the pole couldn't be set on it. And so you learn very quickly to be a little bit humble, but also to take that lesson and also try not to repeat it going forward. So again, learning is just so valuable, an experience. And again, I think from that standpoint, you just never stop learning. You learn to improve, but you also learn to not make the same mistakes over again. And I just can't emphasize that enough.
Now, you talk about this continuing education. We hit on integrity a little bit. Walk me through some of this difficult juxtaposition we see all the time when we're spending time in factories. And as you mentioned, there's this push to get leaner. There's this push to get production out and production volumes, which are, how manufacturers make money, right? I mean, it's about volume. And how that sometimes it runs contrary to what the guys on the shop floor or the inspectors are trying to accomplish, and the net result sometimes that you have of that balance that manufacturers are trying to deal with.
Yeah, I think it gets caught up a little bit in what's good enough, and we run into that. It may not be right, but is it good enough? And I think that's the rabbit hole we tend to fall into sometimes. As an engineer, I could tell you things don't have to always be the way that they're designed on paper, but is it right? No, it's not. And so we end up compromising way too often, I think, these days. I think what we need to do is understand what is the intent of what we're designing, what is the intent of what's on the drawings, but then also follow the codes and standards that have been written by a lot of very, very smart people, and not try to think you know better than the rest of the consensus of the industry that put those codes and standards together. And we tend to, as engineers, you take a lot of pride in what you do, but at the same time, you're not smarter necessarily. You can have different ideas that may be better, but there's a way of getting those ideas put into the codes and standards rather than just not meeting the codes and standards as they're currently written. Mm-hmm. And I think that's the fallacy we tend to fall into sometimes.
Now, you talk a little bit about, and that's primarily on new products that we see that battle going on. You've been around long enough, kind of anecdotally. We recently just did some inspections on some aging infrastructure that you designed. So it shows you how long you've been in the industry. You're outliving some of the structures you designed and are still in the industry. But just hit a little bit on the aging infrastructure piece. A lot of folks think, oh, these are steel poles or lattice towers or even wood structures for that matter. I can just set them out there and they last forever. Your background as a manufacturer through all these different products, and now have been around long enough to see the degradation of basically every type of material that's been used in the industry. Kind of walk me through the aging infrastructure component of not just our business, but of what utilities and retailers are facing every day.
Aging infrastructure is a big problem in the industry right now, primarily because, again, we look at most of the transmission lines and distribution lines that are in service today are probably approaching 50 or 60 years old. They're designed for a 50-year economic life. We think that they should last longer than that, but if they've been maintained, they will last longer than that. The problem is there's not always the incentive to maintain the structures properly over that economic life. And steel corrodes, concrete can degrade, certainly composite materials can deteriorate. And if you're not paying attention to them and doing inspections, a lot of utilities will pay a lot of attention to the electrical components. That's the business they're in. They deliver electricity. So they'll pay attention to the insulators and the conductors and the insulator hardware and all of the things that are key to the electrical part of the system, but they won't look at the ground line and see the corrosion going on, or look at the anchor bolts that are showing signs of corrosion, or inspect the welds that might be starting to fatigue. So there's a lot of other things other than just electrical components that need to be paid attention to. When you start getting to be 40, 50, 60 years old, just as a human body does, just as I'm starting to feel my age at 70, you have to start paying attention to the things that start to wear out.
Yeah, no, absolutely. And when you look back and think about 45 plus year history in this industry, what would you tell a younger version of yourself now with all the knowledge and experience you have? If you could go sit down and have lunch with that person, what would you do the same? What would you do differently?
Well, I would tell them that don't wait to get involved with all of the technical committees that this industry has to offer. I would tell them, don't think you know everything. We hit upon that topic, right? Because you don't. Don't hesitate to continue to learn every day, and don't be afraid to go out and talk to the suppliers, the contractors, the folks that the other folks that we're involved in a lot of different aspects of the critical infrastructure that is the electric utility industry, and try to just understand as broad a picture as you can of what's going on. And but again, don't be afraid to learn and learn from others. That's the best way to learn.
Learn from failure.
Learn from failure.
Learn from successes, right? I mean, you
Exactly.
have to learn from all the above. Walk me through a little bit of the challenge you see in front of asset owners that we work with every day. If you're an executive sitting in their shoes, what challenges you have, what would your message be for them, and how they take on all the various challenges that any business owner or executive at a utility or at a big retailer encounters every day?
Well, that's a big question as well. I think one of the things that that I certainly think that we run into as an industry is we don't necessarily design long-term maintenance and long-term accessibility for inspection into the lines that we build. Obviously, the little distribution lines that run alongside of a road, they're very accessible. They're viewed a lot. But a lot of the higher voltage transmission structures, quite honestly, are not given the prime right-of-way that make them easily accessible for either maintenance or inspection. And as a result, and we've run across that in just some of the work that we've done. Once construction is done, the access roads are demolished and returned back to the way they were. And 15 or 20 years later, when you need to get back into that structure, there are no roads to get back there anymore. And so how do you go about inspecting those structures if you can't get to them? Part of the industry is developed into doing helicopter accessibility, which is a big boon, but that in and of itself has come about because of accessibility issues in a lot of cases. It is a very quick way of accessing lines and structures, but particularly at very inaccessible areas, that's about the only way you can get in. So we need to think about that in a little bit different way, I think, going forward. We need to think about, I would love to see us start to think about ensuring that we're designing structures that are intended to last, 80, 90 years, and which may be a little detail here or there that needs to be taken into consideration from a corrosion standpoint or from a, just accessibility for being able to climb the structure or be able to do whatever we need to do. We do a lot of inspection of welds, so being able to access the welds to inspect them.
And with your 45-year history, as you look forward to the next folks that are going to spend 20, 30, 40 years in this industry, what challenges do you see ahead of them, whether it's utilities, whether it's folks like us that are out trying to maintain this infrastructure? What challenges do you see that they're going to be taking on?
Well, there's different challenges the utilities are facing for sure than those of us that are, involved in managing or helping to manage or assess their assets. But the utility industry is going to continue to grow. Electrification is not going to go away. In fact, probably 25 or 30 years ago, we looked at conservation was going to diminish the amount of electricity needs that we needed. That hadn't happened. Yep. So we thought you wouldn't have to build new power plants because conservation was going to reduce the amount of electricity between higher efficiency air conditioners and so forth. We were going to conserve so much electricity we wouldn't have to build too many more power plants. And that just didn't turn out to be the case. We consume a lot of electricity every day with the advent of electric vehicles and electrification of everything. I mean, we got involved in looking at some things during the winter storm event here in Texas last year. Part of the problem that storm created is a lot of the natural gas compressor stations where they used to run off of what's called fuel gas in years past have been converted to electric compressors now. Mm-hmm. And when you lose electricity, you can't compress the gas to move it from one place to another.
To make more electricity.
So it's kind of an interesting circular reference sometimes, but electricity has become the most critical of all critical infrastructures because everything is driven by electricity these days.
Absolutely.
Which is a good thing for us as a company that we're serving that industry to make sure that electricity can be reliably delivered on the structures and assets that are out there.
Absolutely. Well, Wes, I appreciate all the time today running through your 45-year and counting history. I think your insights are just amazing. I've had the opportunity to be, you be a mentor to me for so many decades, which has been an awesome experience. Whether it was when we were little kids and we're on vacation, you make a stop and walk down a right of way. There probably
you inspected more poles when you were 6 and 7 years old than most 6 or 7 year olds.
Probably, or running around the factory, which I don't think you could do nowadays, and somehow have all of our fingers and toes and whatnot. But
you attended a full scale structure test when you were about 10 or 11 years old.
Yeah. So. Having been you being a mentor for me for all these years, and certainly not just me and folks in our company, your leadership in the industry has been unbelievable to see. And I think a lot of that revolves around your willingness to share and communicate and tell people about your successes and failures, because that's really how you learn. And to see you pass that on to not only folks in our organization, but folks in the industry is unbelievably valuable. And so I appreciate your time today. I appreciate what you've done for our business, what you've done for the industry. I mean, clearly you're recognized as a leader in our industry, and I'm looking forward to the next several years of all of your experience and leadership within our organization. So thank you.
Still a lot more to learn and a lot more things to try to make sure that stay safe.
Yep, absolutely. Well, thank you. Everyone stay safe out there.
Thank you.